Hey guys, this is going to be the video on balancing chemical equations. Let's go over a few guidelines. Just remember that when you're balancing chemical equations, the number of atoms of each element must be the same on both sides of the reaction. This fulfills the law of conservation of mass. While you're doing this, you want to keep track of the changes that you make and the number of atoms throughout what you're doing. And as a general guideline, not always, but you want to save hydrogen and then oxygen for last. And just so you know, it's going to take trial and error to get this right. So anytime you're balancing chemical equations, you're going to get stuff wrong and you have to reshuffle things, and that's totally okay. So while you're doing this, if you have to use your eraser, that's totally fine. So you want to use a pencil when you're doing this. So let's go ahead and get started. What I'd like for you to do is when you do these questions, I want you to try it on your own. Then if you can't solve it, I want you to look at this video, okay? And then see how I got to balancing the equation. What I don't want you to do is just to look at the answers and just write it down and say, I'm done, and turn it in. Anyways, let's go ahead and start. So our first, this is our first equation. Okay, so the first thing that I want you to do is I want you to list all the elements, okay, on both sides and the amounts, okay? So if there's an element on one side, guess what? It has to show up on the other side due to the law of conservation of mass. An element can't just go into a reaction and then it disappears, okay? This is not superstition. This is science that we've observed. Okay, so let's go ahead and count the atoms. On the left-hand side, this is the count, okay? On the right-hand side, we've got this, okay? All right, so looking at this equation and looking at what we've written down, calcium is balanced and oxygen is balanced on both sides. But we can see that sodium and chlorine are not. So on the right-hand side, we've got to get to 2. Okay, we need 2 sodiums and we need 2 chlorines. Okay, so what are we going to do? Well, let's go ahead and put a 2 in front of NaCl, and I circled it. Just remember that 2 is going to apply to both the sodium and the chlorine, so we're going to update it. Okay, so looking at this is now a balanced equation. All you had to do was put a 2 right there at the arrow that I'm showing you. So make sure that you have that down. A lot of times things look worse than they really are. So you saw this semi-complicated equation and all you had to do was put a 2 in front of NaCl. Okay, let's go to the next one. KClO3 decomposes to KCl plus O2. So the first thing you're going to do is you're going to list all the elements, okay, on both sides. So we have potassium, chlorine, and oxygen. And obviously, they're going to be on both sides. All right, so on the reactant side, we have 1 potassium, 1 chlorine, and we have 3 oxygen. On the product side, we have 1 potassium, 1 chlorine, and we have 2 oxygens. So if we look at this equation, everything's balanced except for oxygen. So what are we going to do? The first step that I would do is I would add a 3 to O2. Why is that? Because the O3 and the O2, these oxygens are going to have to end up balancing in the end. So we need to find a common number that they have in common that's bigger than them both, and that's going to be 6. So let me add a 3 to O2. So let me erase what I just did. All right, so put a 3 by O2, what I just wrote. And when you do this, you have to update it. Okay, so we went from 2 oxygens on the right to now we have 6. All right, so if we look at this, everything is balanced except for oxygen on the left-hand side. So in order to get to 6, we're going to put a 2. But whenever you do that, you have to account for everything in that molecule. So we now have 2 potassiums, 2 chlorines, and 6 oxygens. So we've changed some things up. So now oxygen balances, but not calcium and chlorine. So we have 2 calcium and chlorines each on the left-hand side, and we're going to need 2 on the right-hand side. So what can we do? Take a look at KCl. We can put a 2 in front of KCl, and now we've doubled the amount of potassium and chlorine. So now this is a balanced chemical equation. Make sure you have the correct coefficients, and you put that in the correct answer, okay? All right, so let's move on to the next one. We have C plus H2 produces CH4, okay? This is a relatively easy one, but hey, who knows, right? All right, so on the left-hand side, we have 1 carbon, 2 hydrogens. We have 1 carbon and 4 hydrogens. Carbon is balanced, but hydrogen is not. So we need to get to 4 hydrogens on the left-hand side. So what we can do is we can put a 2 in front of H2, and we have 4 hydrogens on both sides. So make sure that you write the correct balanced equation by putting a 2 in front of H2, and this is ready to go. All right, so let's look at the next one, okay? We have H2O plus SO3 produces H2SOS4. So we're going to write down every element. So we have hydrogens, oxygen, and sulfur, okay? And they're going to be on every side. All right, so on the left-hand side, we have 2 hydrogens. We have 4 oxygens. Be very careful how you count them. There's 1 here and then 3 here, so that leads to 4. All right, so we have 1 sulfur. On the right-hand side, we have 2 hydrogens, 4 oxygens, and 1 sulfur. So looking at this, what would you say? Hydrogens are balanced. Oxygens are balanced. Sulfur is balanced. So guess what, guys? This is a balanced chemical equation. It was kind of a trick question, okay? All right, let's move on to the next question. We've got zinc plus HCl produces zinc chloride plus hydrogen. All right, so do what we always do. Let's go ahead and write the elements. So I see zinc, hydrogen, and chlorine. And we're going to do the same for both sides, okay? So we can keep track. Okay, on the left-hand side, we have 1 zinc, 1 hydrogen, and 1 chlorine. On the right-hand side, we have 1 zinc. Okay, we've got 2 hydrogens, and we've got 1 chlorine. So zinc is balanced, chlorine is balanced, but not hydrogen. So what could we do? In order to get 2 hydrogens on the left-hand side, we're going to add a 2 in front of HCl. But by doing that, okay, we now have 2 hydrogens and 2 chlorines, okay? So let's do a double check, okay? Let's go ahead and, okay, zinc is balanced, hydrogen is balanced, but chlorine is not balanced, okay? So we need to get to 2 chlorines on the right-hand side. So what are we going to do? We're going to add a 2 in front of zinc chloride. And by doing that, we've doubled the amount of zinc and we've doubled the amount of chlorine, okay? So you always want to do a check after you've done everything. So chlorine balances, hydrogen balances, but zinc does not. So we have 2 zincs on the right, but we need 2 zincs on the left. So what are we going to do? Exactly right. We're going to write a 2 in front of zinc, and that is going to change it. Now we're going to have 2 zincs on the left. So now let's do a check. Zinc balances, hydrogen balances, chlorine balances. This is the right balanced chemical equation. Make sure that you write that down and hit the pause button if you have to, okay? All right, so let's move on to the next equation. We have Al2O3 decomposes to form Al plus O2. We've got two elements, okay? We've got aluminum, and let me give myself some more room. We have aluminum and oxygen, okay? Quite simple, right? So let's write everything down. On the left-hand side, we have 2 aluminums and 3 oxygens. On the right-hand side, we have 1 aluminum and 2 oxygens. So none of these balance out, okay? I want to finagle with oxygen first. So if you look at the oxygens, we have O3 on the left and O2 on the right. We're going to have to get, the oxygens are going to have to balance out. So we need to find a larger number in common that they have, the smallest number that they have in common. That number is going to be 6, okay? So what are we going to do? Okay, I'm going to look at O2 on the right-hand side, and I'm going to add a 3 to it. By doing that, I now have 6 oxygens on the right-hand side. But now I need to balance oxygen on the left-hand side. So I've got O3. So in order to get 6, I'm going to add a 2, okay, to Al2O3. And by doing that, okay, I now have 4 aluminums and I have 6 oxygens. So oxygen balances out, but not aluminum, okay? So we've got to worry about aluminum on the right-hand side. So what I can do is to get 4 aluminums on the product side, I'm going to add a 4, okay, to Al. And by doing that, I now have an aluminum that's balanced and oxygen is balanced. So this is the correct balanced equation, okay? Make sure you write that down. All right, let's move on to the next one, okay? H3PO4 plus KOH produces K3PO4 plus H2O. Okay, so this looks very intimidating, guys, but fear not, okay? Keep it simple. You're going to write all the elements that you see, okay? Hydrogen, okay, phosphorus, oxygen, and potassium. We're going to write how many of each appear, okay? So we start out with 4 hydrogens on the left. We have 1 phosphorus. We have 5 oxygens, and we have, it looks like we have 1 potassium, okay? On the right-hand side, we're going to start out with 2 hydrogens, 1 phosphorus, okay? Oxygen, we're going to start out with 5. And then we have 3 potassiums, okay? So, generally speaking, you want to save hydrogen and oxygen for last, okay? So phosphorus balances, so we're going to worry about potassium. First thing you're going to do is, in order to get to 3 potassiums on the left-hand side, we're going to add a 3, okay, to KOH. So by doing that, we now have 3 potassiums, but now we have 7 oxygens because we have 3 oxygens here, okay, and then we're going to add them to those 4. So we have 7, and now we have 6 hydrogens, okay, on the left-hand side. That's everything that we did was us putting those 3, that number 3 in front of KOH. All right, so phosphorus potassium K balances out. Phosphorus balances out. But now we need to look at hydrogen and oxygen, okay? We've got, if you look at the product side, we've got 2 hydrogens and we want to get to 6. So what can we do? We're going to add a 3 in front of H2O. And by doing that, we now have 6 hydrogens and we have 3 oxygens here. We're going to add them to the 4. So we're going to get 7, okay? So by doing this, we take a look at every element. Hydrogen's balanced, phosphorus is balanced, oxygen's balanced, and potassium's balanced. So this is the correct balanced equation, guys. H3PO4 plus 3KOH produces K3PO4 plus 3H2O. Pardon my voice, guys. Let's move on. Okay, so we have KNO3 decomposes into KNO2 plus O2. Do what you always do. We have three elements. We have potassium, we have nitrogen, and we have oxygen, okay? And we're going to list how many we have for each side. We have 1 potassium, 1 nitrogen, and 3 oxygen, okay? We have 1 potassium, 1 nitrogen, 4 oxygen, okay? All right, so everything balances except for oxygen. So what are we going to do? If you look at the right-hand side, we've got 4 oxygens. We have 3 oxygens on the left. So they're going to have to balance. So we need a number in common that both of them share that's larger. That's going to enable them to balance. And you get that by multiplying them. So you need 12. You're going to need 12 oxygens on both sides. So let's get to 12. First, we're going to start with, on the left-hand side, we're going to add a 4 to KNO3. And by doing that, we now have 4 potassiums, 4 nitrogens, and we have 12 oxygens, okay? All right. Now, nothing is balanced, okay? But let's take a look at potassium and nitrogen. We've got 4 on the left, and we want to get 4 on the right. So what can we do? We're going to add a 4 to KNO2. By doing that, we're going to have 4 potassiums, 4 nitrogens, and check this out. All right, so we have 4 times, it applies to the O2. So we're going to have 8, and then we're going to add the 10, okay? So now we have 10. Everything balances out. Potassium balances out. Nitrogen balances out. But oxygen does not balance out. We have 10 on the right and 12 on the left. So we need to add, okay? We add 2 more oxygens. So guess what we're going to do? We're going to put a 2 in front of O2. And by doing that, we have 4 oxygens, okay? And we're going to add them to the 8. So that gets us to 12, okay? So this is the correct balanced equation. 4KNO3 decomposes into 4KNO2 plus 2O2. Okay, let's move on to the next question. Okay, we have HCl plus CaCO3 produces CO2 plus H2O plus CaCl2. All right, so we've got 5 different elements, okay? So kind of different. We've got a lot going on, okay? But we're going to keep track of all of them, okay? All right, and that's an oxygen at the end. All right, so here on the left-hand side, we have 1 hydrogen, 1 chlorine, 1 calcium, 1 carbon, and 3 oxygen. On the right-hand side, we have 2 hydrogens, okay? 2 chlorines, 1 calcium, 1 carbon, and we have 3 oxygens, okay? So let's take a look at this. Hydrogens do not balance. Chlorines do not balance. Calcium balances, carbon balances, and oxygen balances. So the only thing we need is HCl to balance out. On the left-hand side, we have 2 of each hydrogen and carbon, but guess what? On the left-hand side, we don't. Well, let's take a look at this. We need to get 2 of each. So what can we do? Go ahead and put a 2 in front of HCl, and by doing that, we now have 2 hydrogens and 2 chlorines. So now everything is balanced, guys. So this is a correct balanced equation. This looked pretty complicated, but all you had to do was add a 2 to the beginning of HCl. We have a balanced chemical equation. All right, so let's move on to the next one. Fe plus H2O produces Fe3O4 plus H2O. Start what you always do. Okay, we're going to list all the elements, and we're going to list the amount that we have for each one, okay? Very well. All right, so iron, we've got 1, hydrogen 2, oxygen 1. Okay, on the other side, we've got 3 irons. We've got 2 hydrogens, and we've got 4 oxygens. So, the only thing that balances is hydrogen, okay? Generally, you want to leave hydrogen and oxygen for last. So let's focus on iron, okay? We've got 3 irons on the right, and we're trying to get to 3 on the left. So go ahead and add 3 to iron, okay? Okay, so now our iron balances out, hydrogen balances out, but oxygen does not balance out. So what are we going to do? We want to get to 4 oxygens, right? So add a 4 to H2O. And by doing that, we have changed the amount of hydrogens to 8, but now we have 4 oxygens, okay? So let's take a look at what balances in the middle, okay? Iron balances out, hydrogen does not, but oxygen does. So we need to focus on hydrogen. Okay, we have 8 hydrogens on the left, and we need to get to 8 on the right because we only have 2. So we're going to pay attention to this H2 molecule. And what are we going to do for it to get to 8? Well, we're going to add a 4 to it, okay? So go ahead and add a 4, and by doing that, we now have 8 hydrogens on both sides. So now everything balances out, okay? Iron balances out, hydrogen balances out, and oxygen balances out. This is a good balanced chemical equation. All right, so let's move on to the next one. We have CS2 plus O2 produces carbon dioxide and sulfur dioxide. Do what you always do. You're going to label all the elements, okay, on both sides. There's an element on one side, it has to be on the other side, okay? Law of conservation of mass. Let's go ahead and label how many we have. We have 1 carbon on the left, 2 sulfur, and we have 2 oxygens, okay? On the right-hand side, 1 carbon, we have 1 sulfur. Actually, let's see what we have here. We have 1 carbon, we have 1 sulfur, and we have 4 oxygens, okay? All right, so what are we going to do? Let's see here. First, let's make sure that we've correctly established how many atoms we have, and I'm going to double check, okay? 1 carbon, 2 sulfur, 2 oxygen, 1 carbon, 1 sulfur, 4 oxygens, okay? So the first thing we're going to do is let's look at sulfur. Okay, sulfur is not balanced, so we need to get to 2 on the right. So go ahead and put a 2 in front of 2 SO2, okay? And by doing that, we have 2 sulfurs, but now we have 6 oxygens, okay? Because we have 2 times 2 is 4, but you got to add the 2, so we have 6, okay? Well, let's take a double check. Carbon balances, sulfur balances, but oxygen does not. So we need to get to 6 oxygens on the left-hand side. So what are we going to do? We're going to add a 3 here, okay? So by doing that, we now have 6 oxygens. And now this balances on both sides, okay? So CS2 plus 3O2 produces CO2 plus 2 SO2. Very well. All right, so let's move on to a new equation. This is a classical combustion equation, okay? Where we have a carbohydrate plus an oxygen, okay? Okay, a hydrocarbon, apologies. So let's write everything that we have, okay? We have carbon, hydrogen, and oxygen, okay? All right, so on the left-hand side, we have 3 carbons, 8 oxygens, or 8 hydrogens and 2 oxygens, okay? On the left-hand side, we have 1 carbon, we have 2 hydrogens and we have 3 oxygens, okay? Nothing balances out, okay? But we want to avoid hydrogen and oxygen last, so let's focus on carbon, okay? So the first thing we're going to do is, in order to get 3 carbons on the right-hand side, we're going to draw a 3. We're going to put a 3 in front of CO2. Now we have 3 carbons, and we have 3 times 2 is 6, but we got to add the 1 oxygen on the out there, and we've got 7, okay? Okay, so let's take a look at what we've done. Nothing is, okay, carbon balances out, but hydrogen doesn't and oxygen does not, okay? So what can we do? Let's take a look at H2O, okay? So let's focus on hydrogen. We've got 8 hydrogens on the left and 2 on the right. So we're going to add a 4 to the H2O, okay? And that's going to give me 8 hydrogens. And now we've got 4 oxygens, okay? Because we do 4 times the 1 oxygen. So we have 4, but we've got to pay attention to the 6 over here. So now we've got 10 oxygens, okay? And let me erase some stuff because we're getting out of control a little bit. All right, so let's see where we stand, okay? Let's do some double checking. Carbon balances, hydrogen balances, but oxygen does not. We've got 10 on the right and 2 on the left. Pay attention to this. We put a 5 up here. Now we have 10 oxygens, okay? So now everything balances out, and this is the correct balanced equation for this formula, okay? All right, so let's move on to the next one. My voice will stay with me. All right, so we have lithium plus H2O produces lithium oxide plus hydrogen. This one's a little tricky and it goes against intuition, guys. So a lot of this is just trial and error, okay? So go ahead and label them on both sides. Okay, so on the left-hand side, we've got 1 lithium, we've got 2 hydrogens, and we've got 1 oxygen. On the right-hand side, we've got 1 lithium, we've got 3 hydrogens, and we've got 1 oxygen, okay? Okay, so what are we going to do? So everything balances out except for hydrogen. So, what I'm going to do, what I ended up doing is I ended up putting a 3 in front of H2O. So what I ends up doing is, it gives me a 6 hydrogens, and it gives me 3 oxygens, okay? All right. Let's take a look at what we have here. So lithium balances out, but nothing else does, okay? The next step that I did was I added a 2, okay, to lithium hydroxide. Okay, and when you do that, you now have 2 lithiums, and you now have 2 lithiums, you now have 4 you know what? Let's go ahead and start this again, okay? Because I think I overdid myself, okay, with the trial and error. And I apologize for this, guys. All right, so let's start all over again. All right, so let's start fresh. I'm going to delete this, okay, everything that I did. All right, lithium, hydrogen, and oxygen. I apologize, guys. It's been a long day, but I want to set you guys up. And I'm already losing my voice. All right, so let's keep count. We've got 1 lithium, 2 hydrogens, and 1 oxygen. On the right-hand side, we've got 1 lithium. We've got 3 hydrogens, and we've got 1 oxygen, okay? The first thing that I'm going to do is I'm going to add a 2 to lithium hydroxide, okay? And by doing that, I now have I've got 2 lithiums, I've got 4 hydrogens, and now I have 2 oxygens, okay? Now, there is nothing that is balanced, okay? Nothing is balanced so far. So what am I going to do? I'm going to look at H2O. I'm going to put a 2 in front of H2O. Now, by doing that, I now have 4 hydrogens and I have 2 oxygens, okay? So lithium doesn't balance out, but hydrogen and oxygen do. So now all I have to do is I need to get 2 lithiums on each side. So I'm going to add a 2 right there, and now I have 2 lithiums. So now we have a balanced chemical equation, guys. So make sure that you write that down, and I apologize for kind of goofing up on the first part of this, okay? All right, so let's move on to the next one. We have aluminum plus zinc chloride produces zinc plus aluminum chloride, okay? So let's go ahead and account for all the elements and the number of atoms of each one, okay? So we have aluminum, zinc, and chloride, okay? All right, so on the left-hand side, we have 1 zinc, 1 aluminum, 1 zinc, and we have 2 chloride, okay? Right-hand side, we have 1 aluminum, 1 zinc, and 3 chloride, okay? So everything balances except chlorine, okay? Now take a look at these numbers, okay? 2 and 3. Eventually, both sides are going to have to balance out. So in order to do that, we have to find the largest number, the smallest, largest number that they have in common, and that is 6. So what I'm going to do is I'm going to add a 3 to zinc chloride, okay? So by doing that, I now have 3 zinc, okay? And now I have 6 chlorine, okay? So aluminum balances, okay? Zinc does not, and chlorine does not. I'm going to pay attention to aluminum or chlorine. So I've got 6 here and 3 here. So what can I do? I'm going to add a 2 to aluminum chloride, okay? So by doing that, I have 2 aluminums, and now I have 6 chlorines, okay? All right, so now let's take a look at what is working, okay? Aluminum doesn't balance out, zinc does not, but chlorine does. Let's take a look at zinc, okay? I want to get to 3 zinc on the right-hand side, so I'm going to put a 3 there, and now I have 3 zinc. And let's take a look at aluminum. I have 2 on the right, so I want to get 2 on the left. So I'm going to go ahead and add a 2 there, and now I have 2. So if I do a check, everything is now balanced, guys. That's the correct balanced chemical equation. Okay, we're down to the final 2. All right, so we have Cu2S plus O2 produces Cu2O plus SO2. All right, so let's write all the elements we have. We have copper, sulfur, and oxygen, okay? All right, so we have 2 coppers, 1 sulfur, 2 oxygen on the left. We have 2 coppers, we have 1 sulfur, and we have 3 oxygens, okay? So everything balances except oxygen, okay? So the first thing I'm going to do is I'm going to add a 2 to Cu2O, okay? Let's do that. I'm going to do that, okay? And as a response to that, I now have 4 coppers and I have 4 oxygens, okay? All right, so the only thing that balances is sulfur. So the next thing I'm going to do is I'm going to add a 2. So I'm going to look at copper. I've got 4 on the right and 2 on the left. So I want to get to 4. So what am I going to do? I'm going to add a 2 in front of Cu2S. So by doing that, I now have 4 coppers, okay? And I have 2 sulfurs, okay? So the only thing that balances is right now is copper. Next thing I want to do is I want to add a 2 to SO2, okay? So by doing that, I now have 2 sulfurs, and I have, be very careful because it's 2 times 2, so I have 4, but I need to add the 2 oxygens, okay? So I have 6 total oxygens. Copper balances, sulfur balances, but not oxygen. I have 6 on the right, but I want to get 6 on the left. So what am I going to do? I'm going to put a 3 in front of this O2, and by doing that, I now have 6. Now this is a balanced chemical equation, okay? Because we have the same number of atoms of each element on both sides. All right, so let's close this up. We're going to do NH3 plus O2 produces N2 plus HO2. Go ahead and label, okay, your elements. And this one's going to be a little tricky. It's going to require a little bit of more higher ordered of the coefficients, okay? So let's do a count. We have 1 nitrogen, 3 hydrogen, and 2 oxygens, okay? On the other side, we've got 2 nitrogens, 2 hydrogens, and 1 oxygen, okay? So the first thing that I did was I added 4 to NH3, okay? So by doing that, I have 4 nitrogens, 12 hydrogens, okay? And the oxygen stays the same. So let's go ahead and look on the right-hand side, okay? I'm mainly interested in the hydrogens, okay? Because I have 12 on the left and I want to get 12 on the right. So what am I going to do? Well, let's go ahead and we're going to add a 6 over here, okay? So go ahead and add a 6 to H2O. And by doing that, I now have 12 hydrogens and I have 6 oxygens, okay? All right, so let's do a little bit of math. So nitrogens do not balance. We've got 4 on the left and 2 on the right. So what are we going to do? Add a 2 to N2, okay? So now we have our 4 hydrogens, okay? Nitrogen balances out, hydrogen balances out, but oxygen does not. We've got 2 on the left, 6 on the right. So what are we going to do? Add a 3, guys. Now we have 6. Now everything balances out. This is a good equation, okay? So, like I said, this is going to take a little bit of tinkering and trial and error. So I apologize for my voice. I'm losing it, but I did want to show you how I got to this.